Okay, when I teach this typically, I would not have put this far. Following the book here, I would have actually just done this section when we learned first about square roots. But what we're going to look at in this section is other kind of roots. So we've seen hints of this as we've done this section. It doesn't have to be a square root. You can also have a cube root or a fourth root or a fifth root. And the key is that the house has the indication of what this is. This is a cube root because there's a 3 there. Square roots we don't show, but it typically, like if you really wanted to be technical, it means this, that there's a 2 there, meaning that this house, it's called an index of 2. And what it means is this. If I had like the square root of 9, we know that that's the same as 3 times 3. Well, this index tells us how many of the same number we need if we want to bring it out. So if it's 2, I need 2 of a kind. Well, if we look at A here, if I have the cube root of 8, that breaks down to be 2 times 2 times 2. It now takes 3 of a kind. Our index is 3. So I need 3 of a kind in order to bring one of them out. Now, you'll get the idea. I think, so sometimes we'll do this and we'll have stuff left over. I think in this section it's always just going to work out in this first video here. So we have an index of 4. I've broken down 81. It now takes 4 identical factors to bring one out. So the fourth root of 81 is 3. And then on a fifth root, it takes 5 identical factors to bring one of them out. And we get 2. Okay, give this a shot here. You don't have to do the house if you see the cube root. The reason why you're going to do this is in our next video we're going to have stuff left behind. But so it takes 3 of a kind. Well, that gives me a 3 on the outside. And I don't know 256. What is this? It's going to be a whole bunch of 2's. Okay, so there's a whole bunch of 2's here. Now we're in the world of 4, so it takes 4 of a kind to bring one of them out. So I can bring out a 2 from this loop and a 2 from this loop, so I can bring out 4. Got to multiply them back together. Okay, I'm pretty sure that 243 is 5 3's, so I can bring out a 3. All right, more of the same. 1,000 is made up of 10 times 10 times 10. You could break it all the way down, but you'd get the same thing. Got to put my little index up there. So I could bring out a 10 because I've got 3 of a kind. 16 is made up of 4 2's. So it takes 4 of a kind to bring out a 2. Little index of 5 up here. Takes 5 of a kind to bring out a 2 in this one for C. All right, now we've got to be careful with negatives inside roots. Now on A here, this can actually be done. So odd roots can be done with a negative underneath, but even cannot. So this one, it cannot be done. We cannot take the square root of a negative number. So there's no way to get 4 of the same number to turn into negative 16. It's impossible. If they're positive, it would be positive. If they're all negative, it would be positive. It can't be done. Now you can do that with odd. So like negative 2 times negative 2 times negative 2. That will turn out to be a negative number, and it's 3 of the same thing. So it can be done. So A and C can be done, but B cannot. Now, how would you work it? Well, I do it the same as, so this is allowed because it's a cube root. So I would break down 64 just like I always would have done and get 4 and just throw the minus on the end. So if you're like, how do I break down negative 243? Just do 243 and then you know it's allowed because this was an odd index. So my answer is just going to be negative 3. Just going to slap that negative back on. So if you look here, you can already see that b cannot be done. It is an even index, so that is no solution. Can't be done. Now if I break down 125, the negative can be done because it's odd. So I'm going to put a negative on my answer and just break down 125, which is 5 times 5 times 5. 3 of a kind lets me bring out a 5. It's a negative 5. Now, fifth power is odd, so I'm allowed to do that. My answer, I'm just going to give a negative, and then I'm going to break down 32. I don't know what that was supposed to be. Okay. Now 5 of a kind lets me bring out a 2. So I just throw the negative on the end. Okay, more of the same here. Lots of big ones that I don't know. That can't be done. Oh no. Let's do 3. Okay, 216 is made up of 3 3s and 3 2s, so I can bring out a 3 and a 2. Yeah, so I can bring out a 6. So this is going to be negative 6. Because it was allowed, because it was odd, I just did the 216, and I just throw the negative on. And then I don't know, 1024, it's going to be 5. I'm going to skip this. I don't know what that would be. It'd be breaking down a whole bunch of numbers, and then you can just throw the negative on. It's going to take 5 of a kind. Okay, so when we throw variables on this, it's the same. We saw this exact idea already. To do A, you've got the square root. It allows you 2 x's, so remember what it meant was like there's an x times an x in there. I can partner them up and I can bring out an x. Well, I can partner these up. Takes 3 n's to bring one out, but I have 3. So I can make that n. This is p. This is y. You see what they're doing. Okay, this is not meant to be a trick. This is this simple. If you're in the world of 2, which is what I call the indexes, you're in the world of 2, you can bring out a b. You're in the world of 3, you can bring out 1w. You could bring out 1m. You could bring out 1q. Okay, I really don't think you probably need another one of these, but here it is anyway. Okay, now things have gotten more complicated, but it's the same thing. Now I'm going to start with the second one because I don't want to write so many of these. You don't have to do this, but we saw this at the beginning. The only thing that's changed, how many do I got? I think the only thing that's changed is that the world, the index, now takes 4 of a kind. So I can bring out 2 z's. Okay, so what you're really doing is dividing, and it works out perfectly in this section, but sometimes it doesn't. So just make sure you're careful here. We have 18 of them. We're grouping them by 3. We could bring out 6 of them. I'm just dividing. So here, if you group them in 4s, it means you're dividing it by 4. So you can bring out 3. Here you could bring out 5. I'm putting them in groups of 3. It means I'm dividing it by 3. And it gets me to the 5th. Okay, pause if you want to try yourself, but it's just going to be c to the 4th and d to the 4th. All right, we've seen all this before. We have numbers in there now and the variables. It doesn't change anything. We're just going to do the numbers like we've been doing and then do the variables separate. We saw this when we were first learning about roots. So they're doing the perfect square approach, but 4 times 4 times 4 is 64. So I can bring out a 4. And you see if I'm partnering up in groups of 3, I can bring out 2 p's. 16 is 2 times 2 times 2 times 2. That'll let me bring out a 2. And I can also bring out 3 q's. Now, what they're doing here with this absolute value sign is not one of my favorite things either. Let me see. Hold on. I'm going to pause this and see if I want to do this. Okay, I will show you this, but I don't count this off on a test. When I first taught this, saw it in the textbooks, I would say, okay, let's do this. It is terribly confusing. But here's the deal. Remember, in an even index, we've got an even here. We were not allowed to have a negative underneath there. So suppose this q to the third. Suppose this had been negative values. If it had been negative, then we'd have a problem here because we're not supposed to have a negative underneath. So what we do is we say, hey, we need to limit this so that this is the positive that's coming out of there because it's not allowed to be negative. So I do not ask for this. And when you move on into higher college algebra, we never keep bringing these absolute values on here. But technically, if you're taking an even index and you're pulling that out of here, for the variable, we would need to indicate that, hey, this has to be a positive by putting in the absolute values. Okay, there's a little bit more to that story, and I don't know if I even want to share it. Yeah, I'm not sure. But let's do these and I'll think about it. Okay, now I'm not going to break down 27 x's. That's a lot of x's. But we know that in the world of 3, it takes three of a kind to bring it out. I can bring out a 3. X to the 27th, it's really division. If I'm grouping them by 3's, I've got x to the third. Okay, now over here, 81 is made up of 3, or 4, I should say, 4 3's. Okay, so it takes 4 3's to bring one out. Now this is division here, so I can bring out, what can I do? That would be 7. Now this is where we would need the absolute value sign if I cared about that. And again, there's a little more to it, but I would not count this off. I do not do the absolute values. It's too confusing, and I think it's unnecessary. Okay, we got one more here. Try this on your own if you want to. Okay, if we're in the world of 3 here, the index of 3, it takes 3 of a kind. So you can bring out a 5, and you see you can bring out 3 p's if I match them up in groups of 3. All right, this I believe is 5 3's. So I could bring out, I'm in the world of 5, so I could take out 1 3. And if I match them up, I could get 5 q's. Okay, so again, this actually, yeah, neither of these. It only happens on even index, so no absolute value signs. And again, I don't care about that, but just trying to mention it. Okay, so that's pretty simple. And I think what we're going to see in our next video is that we're going to have the same concept, but sometimes you can't bring everything out of the house, but we saw that earlier as well.